Okay, 8.2. 8.2 is going to be looking at a specific type of probability outcomes. We actually looked at these at a small scale in Chapter 7 when we did the independent events. In Chapter 8 here in 8.2, we're going to take that idea and broaden it and look at cases that are bigger sets. So these are called Bernoulli's trials because he's the mathematician way back when. I think he's a Greek mathematician. Way back when, who came up with the formula to solve these. All right, again, they always name things after, Pythagorean theorem was named after Pythagoras. And so Bernoulli is the guy who came up with the formula, and so these are called Bernoulli's trials. But what they are is they are whenever we have a binomial random variable. Right? Binomial means there are only two possible outcomes, right? That's the bi part. Two possible outcomes. And so Bernoulli's trials, when we get to Bernoulli's formula, works whenever we have a probability case where there's only two things that can happen. One or the other will happen. And that's all of the outcomes that represent all 100% of the probabilities. There's only two probabilities possible. Right? Probability that this event happens or that event doesn't happen and something else happens. And so what we usually do in Bernoulli's trials is we separate the two possibilities into a success, all right, which, don't get confused by the terminology, it doesn't necessarily mean a good thing. I think the book has a problem where success is getting bitten by a spider, all right, which isn't a good thing, but it's what they're counting. They want to know the probability they'll get bitten by a spider, and so that's what we're calling the success, whatever it is that we're trying to count, all right, whatever the numbers represent. All right, so whatever counting, whatever we're looking for is success. Its complement, which would be not getting bit by a spider, would be whatever we're not counting, or the opposite of what we're counting, right? The complement to what we're counting, which we call failure, which again doesn't necessarily mean a bad thing, it's just not what we're counting. And what these correlate to in Chapter 7 is these Bernoulli's trials are always independent events. And so whenever you go back and you look at the 7.5 notes for independent events, they are the binomial cases. You'll notice that there are only two possible things that can happen. Right? We had an example where people were late to a party. Right? Whether either they come to the party on time or they're late. Right? And so again, winning a contest, right? Either you win the contest or you don't win the contest. Right? And so whenever we had the independent cases, those were binomial outcomes. And so we're going to take those independent cases and look at bigger sets here because we're going to get Bernoulli's theorem. So since there's only two possible outcomes, we have two probabilities. Right? We have the probability of whatever it is we're counting as a success, which we label lowercase p, and the probability of failure, which would be the not success part, they didn't succeed, is q. Right? And their complement, which means those are the only two probabilities and then shit up to 1. So if I know the probability of p, I can find the probability of q by taking 1 minus p, or vice versa. If I want to find the probability of p, I can take 1 minus q, right? Because they're complements of each other. So if I have a 30% chance of p occurring, there's a 70% chance of q occurring, right? Because they have to add up to 1. Like one set of branches on a tree have to add up to 1. Right, the binomial random variable. Right, the binomial random variable counts how many successes that you have, meaning I can do a whole bunch of these. An example we're going to get to is the free throw, right? I can shoot a free throw. Either it goes in or it doesn't. That's it. You shoot a free throw, shoot a basket. It goes in the hoop and you score, or it doesn't go in the hoop and you don't score. Right? Those are your only two possibilities if you shoot. But you can do more than one free throw, right? You can do 2 free throws. Over, if you're practicing, you can do 10, 50, 100, 1,000 free throws, right? And so you can do a whole bunch of these cases. I can shoot a whole bunch of free throws with each of them has two possible outcomes. Flipping a coin is a binomial example. It's just an easy case because there's only 50% chance either way. But that's a binomial, right? And I can do a whole bunch of, I can flip a coin once, twice, 15 times, 20 times, 100 times. It doesn't matter. I can flip it as many times as I want. Each outcome had two possibilities, heads or tails. Right? So it's binomial because there were two possible outcomes for each toss. But I can do many, 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 many of those tosses. Right? And so that's what we mean by the x value represents how many times I do the Bernoulli's experiment. Flipping a coin, shooting a free throw, right, whatever it is. again, my example is a basketball player shoots free throws. All right, given words, the binomial variable. All right, two probabilities, one is success. And again, you can set this up that we typically want to go, we want to count baskets made, right? So I'm going to you can go two ways with this, though. You could count baskets not made, right? But I'm going to count the success being baskets are made. So this would be the number of made free throws. All right? Which means P represents the probability he makes a free throw. So this is the probability he or she makes a free throw. And it would be based on statistical information, right? This is based on statistics, his stats. Q, which would be 1 minus P, would be the probability he does not make the free throw. Right? The complement, right? Not making it. Those are it. Those are your possibilities. You make it or you don't make it based on his statistics. There's a chance he's going to make it. 70% shooter. All right, 70% chance of making it, which means probability of 0.7. And so therefore he's got a 0.3 or 30% chance of not making it, right? Missing it. And so it's a binomial case. And again, he can shoot as many of those as he wants. So you can do a sequence of these. Right? For example, you can shoot 10 free throws in a row. Assuming they're independent, and all of these Bernoulli cases are assuming independence. If you go back and look at independent cases, you can use Bernoulli's formula if you want to. All right, but since those were small cases, we didn't want to use them there. We're going to use them in bigger cases where I'm going to have more than like 2 or 3 people. I'm going to have 10 to 50 to 75 to 100 people. And so we're going to have a formula to use in those cases. All right, Bernoulli's formula. Now, we are required to teach you the Bernoulli's formula, so that is how I'm going to teach it to you. There is a way to do it on your calculator, and if you want a YouTube video the way to do it on your calculator, feel free. All right, I am just, again, in the master syllabus, I have to teach you the formula. Right, which actually the formula is not too bad. If you use the formula, it's pretty straightforward. But if you want to, and you just be careful because there's a little trick to doing it on the calculator, you can use the calculator method, that's fine. All right, but like I said, I'll leave that to you if you want to try to do it with the calculator. I am going to teach you the formula because that is what what we were in the master syllabus, we're supposed to teach you the formula, so I'm going to teach you the formula method. And I actually think the formula method's not too bad. Alright, so to solve using the formula, N means how many times we're going to do something. Alright, I'm going to shoot the basketball 50 times, so that's what N is. Alright, we're going to do throwing darts at a dartboard. Alright, I'm going to throw darts at the dartboard 10 times. I'm going to randomly draw out of 100 people. I have 100 people to choose from, and I'm going to randomly draw from, so N would be 100 people. Alright, so N is how many total tries you have. So I've got 100 people to choose from, so I have 100 people I could pick. P would be the probability of success, usually given as a percent, but you have to write it as a decimal probability. And Q would be the opposite of that, so it would be 1 minus that, the failure case. All right, so the formula is, and it does involve a combinations, right? This is a combinations. The combinations part is just how many different ways, like if you shoot 3 free throws, right, you can make the first, you can make one, right, you can either make the first, or you can make the second, or you can make the third, right, and so the combination sort of, that part kind of counts how many ways can you make one free throw, and then this part's the probability. If you make 1 and miss 2, that counts the probability of making your 1 and missing your 2. And when you see examples, it'll make a little more sense. Alright, so this is the formula that I'll be using. N is the total number of times that you can do something. X is how many times you're going to succeed out of N tries. P is the probability of that success, what's the chance of that success, and Q is the probability you won't succeed, you'll fail at whatever it is you're counting, which again is always the complement. Alright, so we're going to do the basketball example because I just think it's an easy one, so we'll start there. Alright, suppose a basketball player, based on his stats, right, his statistics, right, this is the statistics part of the class, his stats, he has a 82 free throw percentage, meaning 82% of the time he makes his free throws, based on his past performances. assuming each time he shoots a free throw is an independent event. So every time he shoots a free throw, he has an 82% chance of it going in. That's what it means to be independent. What's the probability he makes 4 in a row? So 4 out of 4. And so remember our formula, probability of success is combination n choose x, probability raised to the x, q minus to the n minus x. And so x, I'm going to let x be the number he makes. N is the total time he tries, so 4, and so x is going to be 4, right? He's going to make 4 out of 4. Probability of success was our 82 written as a probability. Probability of failure is 1 minus our 0.82, which would be 18% chance he's not going to make it, right? That's 100% of the outcomes. He makes it, misses it. 82% time out of the 100 he makes it. 18% of the time he misses it. Alright, so there's all my information for my binomial. Then I fill out my calculator. Alright, so probability he makes 4 would be combination, well, he's making 4 out of 4. Probability of success is 0.82. He's going to succeed 4 times. Actually, I'm going to write it lower so I have a little more room to work. Apparently I needed to. So give me a second, I'm writing it again. So combination 4, choose 4. Probability of success is 82. He's going to succeed 4 times, right? So that's what that represents. 82%, and he's succeeding 4 times. Probability of failure is 18. Well, if he's going to succeed 4 times, this is n minus x, so it would be 4 minus 4, which comes out 0. It should make sense. He's not going to fail at all, and so that's what this represents. And these two exponents should always add up to n. This is the number of times he succeeds and the chance of succeeding. This is the number of times he fails and the chance of failing. Well, he's going to succeed 4 times, fail 0 times, right? He's making 4 out of 4. And then this counts how many ways you can do that. Well, how many ways can you make 4 out of 4? If you type in combination 4, choose 4, there's only one way to do that. Then the 4 chances he makes it with the 82, not 84. And then he's never going to miss, and remember, anything raised to the 0 power is also 1, and so this is just 0.82, and the reason why I did this example is to kind of get you to remember what we did in 7.5. This is what we did in 7.5, the probability he makes the first, and the second, and the third, and the fourth. Well, the probability he makes the first is 82, 0.82, times the probability he makes it the second time, which is 0.82, times the probability he makes it the third time, which is 0.82, times the probability, and so it would be 0.82 times 0.82 4 times, which shorthand for that is 0.82 to the 4th. Alright, then you multiply that out. It comes out to 45. So based on his statistics, if he's an 82% free throw shooter, the chance he's going to make 4 out of 4 is about 45% chance. Alright, this actually is a throwback question, so to get you to understand sort of the difference between what we're going to do now in Chapter 8 with what we did in Chapter 7, is what's the probability he makes the first, the fourth, but misses the second and the third. Now, in this case, you don't want to use the formula. Right? You don't, because this is a specific case. It's not asking me for out of 4 tries he's going to make 2. It didn't say that. It said he makes a specific outcome. He makes the first and the fourth, but misses the second and the third. And so in this case, this is the 7.5 stuff where you do not use the formula, because it's a specific outcome. One outcome, right? Instead of the next example, which we'll get to in the next example. It's the outcome. What's the probability he makes the first, made the first, but misses the second. The second was missed. Missed the third, but made the fourth. Alright, that specific case, which is what we did in Chapter 7. Alright, we multiplied out all 4 outcomes with their individual probabilities. Well, the probability he makes it is 82. Probability he missed it was 18. And so it would be 0.82 times 0.18 times 0.18 times 0.82. So for that specific outcome to come, the probability he makes the first, misses the second, misses the third, makes the fourth, is a little bit better than a 2% chance, 0.0218. Alright, so that's what we did in 7.5. What we're doing here in Chapter 8, this is the difference in the question. So here, he made 2 and missed 2, but they gave you a specific order in which he made 2 and missed 2. In the next part of the problem, it says he's going to make exactly 2 out of 4, which nowhere does it say which 2 he made, which means he can make the first and the second, he can make the second and the third, third and the fourth, first and the fourth, second and third, second and fourth, third, so on. There's about 7 different outcomes. This is the case you want to use the formula for, because he's going to shoot, so n is 4, I've got 4 total shots, that's my total. X represents how many he makes. He's going to make 2, right? That's what my X value is. He's going to make 2 out of my 4. Probability of success is 8.2. Probability of failure is 1.8. And so this one I want to use the formula, because it'll take out, it'll take how many cases and the probability of each case. Actually, as it turns out, the probability of each case is this, but then the formula figures out how many cases there are. Alright, so probability he makes 2 free throws in any order. His combination out of 4, he's going to make 2, right? Combination, this tells me how many ways. Probability of success is 8.2. He's going to succeed twice, times the probability of not succeeding, which was 0.18. Well, if he's going to succeed 2 out of 4 times, he's going to fail 2 out of 4 times, in whatever order. And so remember, those should always add up to how many, right? He's going to succeed twice. He's going to fail twice. Those are the probability of succeeding twice. That's the probability of failing twice. Which that's actually going to be the same probability I got up here, right? But I had more than one way I can do that. Well, that's what the combination is doing, is figuring out, well, how many ways can I do that? And so I type in combination, choose 4. So there were 6 ways. He can make 2, miss 2. So 6 times, and then the probability. 0.82 squared, 0.18 squared. And so that comes out 0.82 squared. 0.82 squared, not cubed. 0.18 squared times 6. About a 13% chance. All right, 0.1307. And he makes 1, and again, in any order. So apparently there were 6 different ways you could do that. All right, so make sure you do understand the difference between a specific case, which is what we did in Chapter 7, and a formula case, right, which means there are more than one way he can do it, right? In any order, he's going to make 2 out of 4. All right, the last one, there's at least one of the 4, which again are many outcomes. I can make 1 free throw, right? Probability he makes at least 1 would be the probability he makes only 1, or only 2, or only 3, or all 4. And then all the different outcomes in between, right? This 2 would have been this last case. So if I do it this way, I have to fill out my formula 4 times. I don't want to fill out my formula 4 times. You want to use the complement in this case. What's the outcome I don't want? Well, I don't want the outcome where he misses all of them, right? And so I'm going to use the complement. And you really want to use the complement in this case. 1 minus the probability. Well, the only outcome is that he misses all of them. So he's going to miss all 4. Which would be my random variable x is 0. Miss all 4. And so I only have to fill out my formula once. And actually the 0 case is the easy case. 1 minus the probability my random variable x is 0. So again, I have the same probabilities. So n is 4, x is 0. And I'm going to use those same probabilities in my formula. Alright, so 1 minus combination 4 making none of them. Probability of success is 82, but I'm not going to make any, so 82 raised to 0. Times probability of failing is 0.18. I'm going to fail 4 times. And why this is an easy case, and it's sort of, again, logical, there's only one way to miss all 4 of them. You're not going to make any of them, so the probability of making them is raised to the 0, so that's going to come to 1. And so really all you're left with is that outcome where all 4 are missed, which is 0.18 times itself 4 times. And so it's really 1 minus probability of failing 4 times. And then you type that out on the calculator, and it's a pretty good odds that you're going to make at least 1 if he's an 85% shooter. Alright, the odds, if you're an 82% shooter, the odds that you're going to make at least 1, so 1 or more, of his free throws is almost guaranteed. Not quite. 99.895% chance, but almost guaranteed if he's an 82% shooter, he's going to make 1 of 4 free throws. Alright, so we'll practice more of these in the next videos. That was sort of the setup and getting you to understand the difference between what we did in 7.5 and with the new formula. And like I said, there is a way to do it on the calculator, and feel free. If you want to figure that out, I'm going to leave that for you to do. I'm going to use the formulas because, again, it's what we're supposed to do. And actually, the formulas are kind of nice. It kind of explains to you what's happening, whereas the calculator is more just a plug and chug. You don't really know what's going on. The calculator's figuring, the formula's figuring out how many ways can this happen, and then multiplying by the chance that it's going to happen. Alright, so we'll stop there. The next video is just practicing this outcome.